Hi everyone, welcome to WinPoint online classes. Today we are going to discuss some of the important topics from the chapter Electric Charges and Fields. Today we are going to cover properties of charges. What do we know about charges now? In the last class we have discussed a lot about charge, right? Like positive charges are there, negative charges are there. There are type of interaction between the charges. Similar charge will repel each other, opposite charge will attract each other. Today we are going to discuss some of the properties of charge. Charge is a fundamental property. We are going to discuss some of the law which we need to follow when we are discussing charges. There are three things which we need to learn: additivity of charges, quantization of charges, charge is conserved. We will discuss one by one. First one, additivity of charges. What do you mean by the term additivity? Additivity means adding. How we can add charges? It's a very simple concept. How can we add charges? For example, there are two charges, -2 and +2. The unit of charge is coulomb, right? Coulomb. That we have discussed in class 10. The unit of charge is coulomb. When we are adding charges, which law we need to follow? Is it a vector quantity or a scalar quantity? This kind of things we need to discuss first. Additivity of charges. Charge is a scalar quantity. What do you mean by scalar quantity? Charge is having only magnitude. There is no direction for charge. Vector is having magnitude and direction, like force is a vector. It is having magnitude, amount is there, at the same time it is having direction. So there are certain rules which we need to follow when we are adding this force and velocity, acceleration. There are some rules which we need to follow when we are adding these quantities. But when we are adding a scalar quantity, we can add like algebraical adding. We can follow algebraical adding. Charge is not having any direction. Because of that, we are adding charges algebraically. Algebraically, what do you mean by this algebraically? Like for example, we are considering some charges. Charges Q1, Q2, Q3, etc. up to Qn. Here you can see that there are Q1, Q2, Q3, etc. up to Qn. When we are adding, how we can find total charge here? Just add it. Q is equal to Q1 plus Q2 plus Q3 plus etc. plus Qn. Just adding, then we will get total charge. That is algebraic addition. Let us discuss this with an example. There are some charges. We are considering some charges. -2 coulomb, -4 coulomb, -5 coulomb, -7 coulomb, 8 coulomb and 7 coulomb. How can we add this? Just add all the values. -2 plus, -4 plus, -5 plus, -7 plus, 8 plus 7. We need to add all the values. What will be the answer when we are adding this value? -2 plus -4, -6. -6 plus -5, -11. -11 plus -7, -18. -18 plus 8, -10. -10 plus 7, -3. So the answer is -3. Next one, quantization of charge. What do you mean by this quantization? Like when we are rubbing two objects, we have discussed frictional electricity, charging by friction. When we are rubbing two objects each other, there will be charge formation. The reason for charge formation is some of the electrons are jumping from one object to the other object. When the electrons are jumping, that time the charge will transfer. Okay. Because of this excitement of electron, that is the reason for the charge formation. One electron may jump, two electrons may jump, three electrons may jump, but half electron, that's not possible. 1.5 electron, not possible. 2.5 electron, not possible. Only whole number. 1, 2, 3, 4, 5. 1.5 is not there. 2.5 is not there. This is called quantization of charge. When we are considering an object, that object is having charge. That should be integral multiple of the charge of electron. It can be 100 E. It can be 10 E. It can be, E means charge of electron. It can be 1000 E. It cannot be 0.5 E. It cannot be 1.5 E. This is called quantization of charge. Q equal to Ne. That is a basic equation. N is integer. All charges are integral multiple of charge of electron. What is charge of electron? It is 1.6 into 10 raised to -19 coulomb. So when we are considering any of the object, it can be 10 electron. The charge will be 10 E, 100 E, 156 E. Electric charge is always an integral multiple of E, is termed as quantization of charge. So charge of an object is always integral multiple of E. The charge of electron is 1.602192 into 10 raised to minus 19 coulomb. Next one. Charge is conserved. What do you mean by this conservation? We are familiar with law of conservation of energy, law of conservation of mass, law of conservation of momentum. Similarly, we need to learn law of conservation of charge. Let us discuss this with an example. There are two objects. What is the charge of this object now? We are considering two objects. Okay, in my hand there are two objects. What is the charge of this object now? 0, because these objects are neutral, there is no charge in it. When we are rubbing these two objects, what is going to happen? Yes, there will be transfer of electrons. Electrons will transfer from one object to the other object, isn't it? Electrons will transfer from one object to the other object. For example, 5 electrons are in action. There are 5 electrons, they got energy and they are going to transfer from one object to the another object. There are two objects, one object is losing electrons, one object is getting electrons. The object which is getting electron, what would be the charge? It will be minus 5 because it got 5 electrons, right? One object is losing 5 electrons. What would be the charge of that object? It will be plus 5. When an object is losing some electron, it will be plus charge. When an object is getting some electron, it will be minus charge. So here 5 electrons are transferring. So one object will be plus 5, other object will be minus 5. What is the total charge? Plus 5 plus minus 5. Plus 5 plus minus 5 means it is 0. Before rubbing, total charge was 0. After rubbing also total charge is 0. Total charge is always constant, right? No new charges are either created or destroyed. We cannot create a charge, we cannot destroy a charge. Only charges are transferring. When two objects are rubbed each other, electrons are transferring from one object to the other object. Total charge of an isolated system is always conserved. That's all for today. In the next class, we are going to discuss Coulomb's law. Thanks for watching.